Today I'm going to demonstrate the use of the Vernier Charge sensor for use in the classroom. It comes in a box, sort of like this. And I'm sorry that this video is going to be shaky because I'm doing this with one hand. Alright, so there's the charge sensor. Little black box. I usually don't like using this kind of device in the lab because, you know, who knows what's going on with that, and the students definitely don't either. However, it gives us some great results that are very hands-on, and they do consistently make good sense. Mainly in this lab, I set it up just to demonstrate methods of charging. Students will investigate how to do that. They'll come up with their own procedures and so on. But the other supplies you're going to need for setup include, of course, for use, some kind of element that will gather charge. So we're going to be just rubbing this in the cloth. There's other things you can use as well. I recommend some kind of fur if you have it. That works a little bit better than this felt, but you can't get it very often these days. But other things, they got styrofoam objects, metal objects, plastic, like plastic rods, plastic rulers. Different kind of plastics have different results, so you can try those out. But beyond that, for setting up the charge sensor, you need the sensor itself. LabQuest works great. Some alligator clip wires. I've got 3 black wires and 1 red wire. Wire is a wire, but the different color coding does help in this case, as the charge sensor does come with a couple of different color wires. Other things you're going to need, I've got a big food service tray. This was the foil cover that I fashioned into a bowl. This works out great. I love this bowl. You can also make some smaller bowls. Just be careful, the edges are really sharp. So I tell the students that beforehand when there's another food service tray. I generally set up 3 stations, 2 of them for smaller objects, and I had 1 larger food service bowl, food service foil bowl I fashioned there for the larger objects. I also have a plastic tray. The reason for all this, these food service pieces here, is they're large. It gives them some space, some separation from the table, and that is helpful for getting better results. But first you need a grounding base so that any charge from the surface or surroundings doesn't really affect, or at least minimizes the effect of the surroundings on the charge sensor reading that we're going to get later on. So just put that tray down as a base. Put that big plastic base in there to separate, to insulate it from the ground, which we're going to ground here in a minute, and put the bowl on top. So that just separates the bowl, and that'll allow us to basically dip our objects in there later on. All right, now I'm going to set up the wires. I always do this near the sink because that gives us a good ground. Just make sure usually the school plumbing is grounded. So just once you verify that, it works great. And you can clip that ground to there. So there's what it looks like. Ground all the way to the sink there. Then I'll take another one. This one I just clip onto here. And this one will be used later on. We're going to be able to ground the bowl when it is necessary to do that. So I'll just leave that right there. And the last 2 wires, the red and the black, I use just as extensions because the charge sensor comes with these kind of short, stubby wires right here on the end. And it's really hard to set up a ground and connect it to the bowl. So I just like to extend those wires out a bit. But you'll take the charge sensor, plug it into the channel 1, 2, or 3. There we go. Should light up. It will not say 0 at first. It'll probably say some funky number here. It's like +3. Then what I'm going to do is connect the red wire to there on the charge sensor, and the other side of the red wire will go to the bowl. So that's what's actually going to take the charge reading, but it needs, because this works on voltages, it needs something to compare. So that's where the 0 or the grounding comes in. We're going to clip the black wire to here, and I'll just take it back to my wonderful ground there. So ground goes to the base, also goes to to the charge sensor. And we're also going to have a third one that we'll be able to touch to the bowl in order to zero it later on. Actually, let's do that. So right now I'm reading kind of a large number. So the way you zero it, and this is something you'll need to teach the class before they get into the lab, is just clip it onto the bowl, and then on the charge sensor there's a little gray button for zeroing. When you press that, it zeroes it, and because we're grounded, all that, it tends to stay zeroed. We'll take that off now, and now the only thing that's touching the bowl is the red wire. It's reading close to zero, depending on the amount of humidity in the air. More humidity means less charge action, so that's a good thing for reading, but it's a bad thing for actually charging objects. Today's a kind of a dry day, so I will rub this a little bit and we'll see what happens. So in order to take a reading, simply dip the object into the bowl. Try not to touch the sides. And when you do that, let's see. So there's nothing in the bowl right now, and now I'm going to put the cup in the bowl. And you see a definite charge change. This is a negatively charged cup. We're not going in for any quantitative data here. We're just looking for some qualitative data. Just the fact that it is a negatively charged cup. Sometimes the cloth, you might get more of a positive change, but cloth tends to disperse that charge rather quickly as styrofoam keeps it well. So you usually don't see much happening from the cloth. But students can try out a lot of different things to dip in there. The last thing I want to demonstrate is charging by induction. This is a great way to show it because it is kind of a complicated process. First I'm going to try to get a good zero out of it, so clip it on there and zero it as zeroed as possible. Now, to charge by induction, I want to try to push the electrons in the bowl out into the ground using my negatively charged cup. So when I put the cup into the bowl with it grounded, you'll see that nothing really changes here. Out of the bowl, in the bowl. You didn't see me do that, but out of the bowl, in the bowl, and nothing really changes. So this next step is going to be hard for me because I'm trying to work with one hand. Here I'm going to hold the cup in the bowl as I take the grounding clip off. Okay. So you notice the charge changed a little bit. However, when I take the cup out of the bowl now, the bowl is now positively charged with no cup. So a negatively charged cup, while it's grounded, chases the electrons from the bowl into the ground, into the earth. When you disconnect that ground, there's no pathway for the electrons to get back in. So then when you remove the cup, I have to do that. Removing the cup then leaves a positive charge behind. And that's it. Hope this was informative.